Math Hoppers. In this video lesson, we are going to learn how to solve equations with variables on both sides. When we solve equations with variables on both sides, there's really only one thing we need to consider that we haven't had to consider before, and that is to gather the variable expressions to one side of the equation. And which side we choose doesn't matter, but let's say we want to make our lives easier, and we do so by avoiding the side that creates negative variable expressions. And we'll see what that means in a second. So we have the equation 2x plus 4 equals 9x minus 17. So this is an equation that has variables on both sides. A common misconception, however, is to think that there are two unknowns in this equation. There is simply one unknown. There are two instances of x, one on the left side of the equation, one on the right side of the equation. They are not two different unknowns. They are not two different variables. If they were, you would see different letters representing each. Since there's just one letter, just x on this side and x on that side, we have one unknown, one variable that is present on both sides of the equation. So now let's see how we solve this. All right, so if the variable expression on the right side of your equal sign, so the 9x here, is larger than on the left side, the 2x, we are going to gather all of the variable expressions to the right side. So in this case, we are going to move everything to the right side of the equation because 9x is larger than 2x, so we will subtract 2x from both sides of the equation to avoid having a negative x expression. When we do that, we get 4 is left on the left-hand side, 7x minus 17 is left on the right-hand side. Now we just have a two-step equation that we can solve for like we always have by first working outward from the constant, the furthest from the variable, to the coefficient, the closest to the variable. So let's get rid of that negative 17 we just talked about. The opposite of negative 17 is positive 17, so we're going to add 17 to both sides of the equation. When we do that, we get 21 equals 7x. Now, x is still not alone. There is a 7 multiplied to it. The opposite of multiplying by 7 is to divide by 7, so we will divide both sides of the equation by 7, and we will see that x equals 3. And just in case it gives you the heebie-jeebies to see the x, the variable on the right-hand side, we will flip it and write it like you like. X equals 3 with x on the left-hand side. Okay, let's look at an expression now where the variable expression on the left side is larger than the right. So in this case, we have 9x minus 3 equals x plus 5. In this case, the 9x on the left side is larger than the x on the right side, so we are going to gather all of our variable expressions over to the left-hand side. We do that simply by saying I want to get rid of x, so I subtract x from both sides of the equation. We get 8x minus 3 equals 5. Now we have that two-step equation we can solve like we always have. We first get rid of that negative 3, right? Get rid of the constant first, then the coefficient. Think about the ribbon and then the wrapping paper. So what's the opposite of negative 3? Positive 3. So we add 3 to both sides of this equation. When we do so, we are left with 8x on the left and 8 on the right. X is still not alone. The opposite of multiplying by 8 is to divide by 8. So let's divide both sides of the equation by 8. When we do that, we see that x equals 1. Now let's look at an equation that has what we call infinitely many solutions. So in this case, we have 3 times the quantity x plus 3 on the left-hand side, and we have 3x plus 9 on the right-hand side. We have two options when we start this. We could distribute the 3 on the left side of the equation. In fact, most often we distribute as soon as we see it. That's the first thing we do in an equation. But in this case, because everything on the right side is divisible by 3, we could actually divide out the 3 first. We could say divide by 3, divide by 3, divide by 3. However, I don't love that as an option for a few reasons. First of all, when you make the decision to multiply or divide in an equation, you must multiply or divide every term. So it is easy to forget. It is easy to say, oh, 3 divided by 3, and then just 3x divided by 3 and forget the 9. Another reason is if we distribute first, we're going to see something pretty cool. So we are going to stick with distributing. Let's distribute this 3 and see what cool thing we find. 3 times x is 3x. 3 times 3 is 9. When we rewrite that, we get 3x plus 9 equals 3x plus 9. notice that we have the same exact expression on both the left-hand side of the equation and the right-hand side of the equation. This means you will have infinitely many solutions. Any value you choose to put in for x will create the same value on the left side as the right side, clearly because they're identical expressions. But let's go ahead and solve it just to show you. If we subtract 3x from both sides, 3x minus 3x is nothing. 3x minus 3x is nothing. We are left with 9 equals 9. Anytime you get a equals a, or the same number equaling itself, there will be infinitely many solutions. Think about it. How many times does 9 equal 9? Well, every time. 9 equals 9. That's what it equals. Put this in a different way. Infinitely many solutions simply means you have the same equation on the left and right hand side, so every x value will result in the left and right side matching. It means simply that there are infinitely many solutions. You couldn't count them. Every value will work. Don't let infinitely many solutions trip you up. Now let's look at something that has no solution. On the left-hand side, we have 2x plus 9. Right-hand side, we have 2x minus 8. It might already look weird to you. You might already think 2x plus 9 can't equal 2x minus 8. Okay, let's just go through the motions anyway. Okay, let's say we were looking at this equation and we wanted to determine which side to move the variables to. Well, when we did that, we'd see, well, the left side has 2x, the right side has 2x. Neither of them have a larger variable expression because they are the same. In this case, my only choice is to subtract 2x from both sides of the equation. So let's do that. 2x minus 2x is nothing. I wind up with 9 equals negative 8. That doesn't make sense. There's no way that makes sense. 9 doesn't equal negative 8. So 9 doesn't equal negative 8. Because 9 doesn't equal negative 8, and because it will never equal negative 8, the result is that no solution exists for this equation. When you get something weird like this, oftentimes we think, oh, I've done something wrong. And that's a possibility. You might have made a mistake somewhere in your computations. But just because you get something weird like 9 equals negative 8 doesn't mean you for sure made a mistake. It could just mean there are no solutions. Anytime you get some result A equals B, where A and B are different numbers and they for sure don't equal, there's no solution. Okay, let's just do this ugly equation, because a lot of times we see in our textbooks, there's super nice equations in the examples where they're teaching you. And then you get to your homework or test and you see the ugliest thing you've ever seen. So let's do one like this. What are we looking at? We have 3/4 times the quantity 12 minus 8n equals 2 times the quantity 5n plus 1. So we have to distribute. Distributing comes first when we solve, but we have to distribute on both sides of the equation. It doesn't really matter which one you do first. We're going to distribute both sides and then clean it up. So let's start with the left side. We have 3/4. We have to distribute to 12 and to negative 8n, right? Don't lose your negative here. So 3/4 times 12 plus 3/4 times negative 8n. We'll clean that up later. Let's look at the right side and distribute that 2. 2 times 5n, that's going to be much easier. That'll be 10n. And 2 times 1. That'll be easier. But let's clean it all up now. Let's simplify. Okay, so 3/4 times 12, or 12 over 1. When we do that, 4 goes into 12 3 times. 3/4 times negative 8n. When we do that, 4 goes into negative 8n, negative 2n times. Think about this. 4 divides into 4 once, goes into 8 2 times, right? So the only thing we divided was the 8 and the 4. So the negative 2n is left. On the right side, we don't really have anything to clean up. This is going to be 10n, this is going to be 2, but we can do that all together. So we get 3 times 3 over here, 3 times 3, because we had 3/4 times 12, and that's going to be 9, plus 3 times negative 2n will be negative 6n. So we get 9 minus 6n equals 10n plus 2. Now, we simply have variables on both sides, which is, well, that's nothing now after this video. So what are we going to do? We are going to avoid a negative variable expression. We have a negative 6n over here. We have a positive 10n over here. we of course want to add 6n to both sides of this equation. When we do that, we get 9 equals 16n plus 2. Now we have a simple two-step equation. We have to subtract 2 from both sides. We are running out of room, so let's make some more room. When we subtract 2 from both sides, we get 7 equals 16n. 16 is multiplied to n. The opposite of multiplying by 16 is to divide by 16. Divide both sides of the equation by 16. We get n equals 7/16. Notice I didn't even write the variable on the right-hand side because I know we don't like it. Okay, there was a lot in this video. If you're going through your homework or if you're doing a quiz attached to this lesson and something doesn't make sense, you should be subscribed to our YouTube channel. Go ahead and submit your problems there and we will make you a custom solution. Until next time, Math Hoppers, take it easy.